Barakatuh. Bismillah ar-Rahman ar-Rahim. This is the next first lesson of this week, and we have finished Unit 3 in last week, which is the quantitative equilibria. Hopefully you have done all the lessons, completed all the assignments, reviewed your unit with the help of the activities I have set, and solved some past paper questions. And also checked your answers with the past paper question marking scheme I have uploaded, right? In case of further problem, you can contact me and Mr. Faisal to discuss about any doubt you still have in this unit, right? This week we're going to start the new unit, which is called the electrochemistry, and this starts with the basics of oxidation and reduction. Some of the parts of this lesson you have already done in your IG, but anyway, I'll go through each one of them in detail with some specific examples to explain you everything what you mean by oxidation and reduction. All right, so let's start. Bismillah ar-Rahman ar-Rahim. So you've done oxidation and reduction. So the oxidation is very simple logic to understand. Oxidation using the word oil rig. Now oil rig means oxidation is loss of electron, and the reduction means gain of electrons. Now when the electrons are lost, then where do we write down? Where do we write now in the equation? So if you see electrons are lost, those electrons are written on the product side. I will give you all examples, right? The another definition of oxidation is using an element called oxygen. We have done it in organic chemistry. So oxidation means the gaining of oxygen atom or addition of oxygen atoms and removal of hydrogen atom. So if you see oxygen is added or hydrogen is removed, we can say the oxidation is happening. There is another way which is very important way, which is using the charges. And we do have a name. Charges means Na positive, Cl negative. If I write Cl2 means no charge, neutral. We do have a very technical term used in this unit which is called the oxidation state. So oxidation state is nothing but the charge on any atom. Okay, if there is no charge, we will consider it neutral and we call it zero, oxidation state of zero. If the electrons are removed, that means something negative is going out of that atom. So when the negative is out, automatically charge is increased. When you see increase in oxidation state, again the oxidation happening, right? So right now, until now, we have done four definitions: electrons, losing of electron, addition of oxygen, removal of hydrogen, and increase in oxidation states, or simply increase in charge. There's a fifth definition which is specifically linked with this unit. We do have one specific value which will tell you whether oxidation happening or reduction. We call it electrode potential values. So if you get some negative electrode potential value or lower E value, we can say oxidation happening. So you don't have to memorize any E value. We just need to understand and apply what is E value and what information it can give us. So if you get a lower E value or negative electrode potential values, so most likely oxidation is happening. Now you have five definitions for oxidation and exactly opposite definition for reduction. So if it is loss of oxidation is loss of electron, reduction will be gain of electrons. How would I know electrons are gained? The electrons will be on the reactant side. Oxidation is gain of oxygen, addition of oxygen atom, and reduction will be removal of oxygen. And same opposite, everything is opposite. Electrode potential value, if you get a positive electrode potential value or something higher electrode potential value, then we can say the atom is most likely to undergo reduction. That's the main idea. And I would like you to write down this table in your notebook and then move to the next slide where I will explain some examples. Okay. So These are the examples I've given you, and we need to identify the atoms getting oxidized or reduced with a specific reason. For the first one, nitrogen goes to nitrogen dioxide. What's the change? The change is oxygen is added. Whenever oxygen is added, we can say it's oxidation. Next one, hydrogen is added. And when hydrogen is added, we call it reduction. Reduction because hydrogen atoms are added. Third one, Al2O3 goes to Al. It had some oxygen, now it's gone. So reduction because the oxygen atoms are removed. Fourth one is actually Cl2. There is no charge in it. We will consider it as 0. Now we have a Cl negative charge. So 0 become negative. That means electrons are gained. Or you don't have to mention electron. Look at the charges. And the charges decrease. We call it reduction. Decrease in oxidation state. Apply here plus 2 to Fe was 2 plus. Now it goes to 3 plus. So the oxidation state increases. So whenever oxidation state increases, we call it oxidation. Fifth one, last one, plus 2 becomes 0, decrease in oxidation state. So when decrease in oxidation state, we call it reduction. Correct? Now, let's have one more slide of examples with something very complicated, not complicated, different way of. More examples. So these are the 4 examples I have, including the electrons. So now we will decide. Look at the first one. What do you think it is, oxidation or reduction? You have to explain in terms of electron right now. So I'm giving you 5 seconds to think about the first one. Electrons are being written on the product side. So that means electrons are lost. And whenever we have electron loss of electron, we can say oxidation is happening. So iron is losing 2 electron. That's why it is oxidation. How did I know? I knew from the placement of electrons. If electrons on the product side, we would say they are released. They are some part of product. That means they are removed from Fe. It's oxidation because electrons are lost from where. You need to be very, very specific about the reasons now. You just don't say electrons are lost, you say from where electrons are lost. So everything is happening on the reactant. So iron is losing electron, that's why we would say iron is oxidized. Next example, copper 2 plus gaining 2 electrons. How did I know? Because they are on the reactant side. Or you can see the charges decrease as well. So both logics applied, but we have to specifically talk about the electrons here. Reduction because copper 2 plus is gaining electron. Here oxidation because electrons are lost from sodium. And gaining electrons reduction because Cl2 is gaining 2 electrons. That's what, how would you, and on the other way, if you think oxidation is happening, you must write down electrons on the product side. And if you think reduction is happening, you must write down electrons on the reactant side. We will have a task for this, inshallah, in this lesson. All right. Now, 2 more terms we need to know, oxidizing agents and reducing agents. Agents always have some specific task to do. An oxidizing agent is having a task to oxidize other. Oxidizing other means giving them oxygen, removing their electrons, or removing their hydrogen, all those stuff. Now, if an oxidizing agent is giving oxygen to someone, what is happening to itself? It is losing the oxygen from itself. So oxidizing agents will oxidize others, but what will happen to itself? It will reduce. So for the sake of others or to oxidize other, oxidizing agent must reduce itself. There is no oxygen, there is no electron from somewhere. Something happened between oxidizing agent and the reactant. we are going to oxidize. So their substances undergo reduction. They must undergo reduction themselves to oxidize others, sacrificing one to help other. And the other term is called oxidants, short form. And same is applied for reducing agents. Reducing agent has a specific task to reduce other. In order to reduce other, one must oxidize itself. So anything that is getting oxidized, definitely it is going to reduce someone. So that thing is called reducing agent. Okay, it's very confusing. Agents always do opposite to themselves. So reducing agents are the substances that undergo oxidation themselves to reduce others. Very, very simple. Simple, but sometimes confusing. So I have some tasks to do next lesson. The other term for them is reductants. Some example now. 3MgO, 2Al goes to Al2O3 and 3Mg. Do not worry about these numbers. These numbers are just for balancing and used for stoichiometry and moles purpose, not now. Look at the actual formulas and then decide what's happening. So what is happening to MgO? So MgO goes to Mg. So you see oxygen is removed. Whenever oxygen is removed, we can say this is getting reduced. So anything that is getting reduced undergo reduction itself must be an oxidizing agent. So MgO is the oxidizing agent in this reaction. Let's talk about aluminum. Aluminum goes to aluminum oxide. What is happening to aluminum? Oxygen is added. When oxygen is added, that means aluminum is getting oxidized. So anything that is getting oxidized is called the reducing agent. So there could be four different questions using one single equation. They might ask you what is getting oxidized, what is getting reduced. And they might ask you to identify the substance which is oxidizing agent and reducing agent. So you see, oxidizing agent always get reduced to oxidize others, and reducing agent always get oxidized. Okay, that's very important part. Now all you have to do, go to your classwork document and open this task. You see this task? So for the first, I have already done it. So substance getting oxidized is aluminum, and substance getting reduced is MgO. So reducing agent will be is the one getting oxidized, and oxidizing agent is the one which is getting reduced. You just need to write down the elements here, looking at the equation, identifying the substance getting oxidized, substance getting reduced. All right. So if you do not understand, go back, rewind the video, and watch this part again. All right. I'll move to the next part of the video. Standard electrode potential. Now that's an advanced level topic now. So whenever you dip a metal in its own solution, like I have copper rod and I dipped in its copper sulfate solution. I have silver rod, I have dipped the silver rod in its silver nitrate solution. I have gold rod and I have put in a gold nitrate solution. Zinc rod, zinc solution. That combination is called half cell. Okay, so you need to know this term from now on, half cell. So when a metal rod depends on solution, there will be an equilibrium between the ion and the metal itself always. So this equilibrium is represented either short way like this, because copper is dipped in its own solution. This is how we write down first ion, then rod, metal, and there is an equilibrium between them, copper 2 plus gaining 2 electrons. Why gaining 2 electrons? Because the charge is 2. It's dipped and copper rod. It's always in equilibrium. Got it? Another example, iron dipped in iron 3 solution. You always write down like this and you will get a table in your exam where we will give you all the values of this one. Okay, Rn 3 plus gaining 3 electrons. Why 3 electrons? Because 3 plus charge. Correct? So it's always in equilibrium. If you apply some higher positive potential or higher potential, if you connect this with a battery which is having higher potential, most likely forward reaction will happen. And if you move a lower potential, most likely backward. So to understand this topic now, we will explain it later when I do the next lesson, just to understand. There is an always a potential where we get the equilibrium. If sometimes you get higher potential, it will go forward. Voltage, higher potential means higher voltage from the battery. If you have a lower voltage, it will go backward. Forward is oxidation, forward is reduction, sorry, and backward is oxidation. But there will be a value where both are happening simultaneously, which is called equilibrium. Standard electrode potential is the voltage where the equilibrium is achieved. Okay? You don't have to understand fully, you just need to identify the actual idea, which is the values. If you get a positive or higher value, reduction is more likely to occur. Reduction means gaining electrons. And if you get a negative or a lower value, more likely oxidation is happening. This is the most important part. This positive value or higher value goes to reduction, negative value or lower value will go to oxidation because it is equilibrium and one time one will happen. Got it? So half cell is something when dipped in its own solution. Potential is the value at which we get equilibrium. If you get a positive or higher value, on comparison, reduction is happening. If you get a negative or lower value, oxidation is happening. Alright, let's do some examples. Iron 2 has electrode potential value of this. Copper 2 has electrode potential value of this. I have taken this from a table and you will also get a table. So when you look at it very carefully, iron is negative value and copper has positive value. Negative value means most likely oxidation is happening and positive value means reduction happening. When I connect both of them, so this will be reduced, this will be oxidized. So how would I know? I will explain everything now. So E naught is positive in this case or higher, so reduction will happen. Reduction means gain of electrons, and I will write down 2 electrons on the decrease in oxidation state from +2 to 0. So copper 2 ions plus 2 electrons giving you copper. Okay, for the next case, iron has a lower E value, most likely oxidation will happen. Oxidation means loss of electron and the electrons are written on the product side. So this goes to backward. Negative means backward. Iron goes to one simple logic. If you get a lower value, you go backward. So iron losing 2 electrons to give you iron 2. So iron losing 2 electrons to give you iron 2. Correct? Let's have one more example. Cobalt 2 plus in cobalt minus 0.2, Al3 plus in Al minus 1.6. They both are minus, they both are negative. Now when they both have same charge, we need to look at the higher value and the lower value. So looking at the values minus 0.2 and minus 1.6, which one is higher and which one is lower? I'll give you 5 seconds to think. Alright, so minus 0.2 is higher and minus 1.26 is lower. Minus, remember. So we can say higher or less electrons, so E values, so it will undergo reduction. Reduction means gaining electrons. So you can see copper 2 ions gaining electrons to give you copper. Copper 2 ions gaining electrons to give you copper. Aluminum has a lower value, so we will go oxidation in it. Oxidation means loss of electron. So aluminum goes to aluminum 3 plus 3 electrons. So for oxidation, you go backward, aluminum to aluminum 3. For reduction, you go forward, copper 2 to copper neutral. For reduction, you gain electrons. For oxidation, you lose electrons. Alright? Now you have to go to your classwork document. In the classwork document, I have written all the values. So two examples what I have done, I have copied down here, and the other two examples, other six examples I've given you. You can go back to the next page. All the values are here. From here, you will decide which one is going to oxidize and which one is going to reduce. So you need to identify the substance getting oxidized, and it's half equation like this. Substance getting reduced, half equation like this. Half equation is something with electrons on reactants or product. All right, students. So hopefully you understand. In case of any problem, you can discuss with me in our or maybe discuss with Dr. Faisal during our timetable contact time session. All right. Have a great day.